Hey guys, so it's Mr. Aguilar here. It's about 3:30 right now. I finally got done with practice, but I want to give you guys some review. This is for pre-calculus, and it's going to help you guys out with tomorrow's test. I'm going to try to run through these as fast as I can to give you guys more time to practice. I'm not going to really take time to delay, so please make sure you guys are taking the time, stopping the videos, hitting record, and continuing. We covered several problems today, and I'm going to kind of skip through the ones we kind of already done already. So if you want to have practice, there's a section at the bottom of here that kind of relates to problems that we're doing. You can take those on your book, check them out, go to the relative problems. They're all odd, so you can go to the back and find the solutions to them. I'll be here around 6:30 tomorrow morning if you need help to review a little bit more. So here we go. The first problem that we're going to be able to get here is simplify out this fraction. One thing that we want to be able to do here is go ahead and create a common denominator between them. And we're seeing that we're already getting quite a bit of different terms here. So this one is going to kind of stay the same. It's going to be x plus 2. This one doesn't change. The one right next to it is a difference of squares. So we're going to go x minus 2, x plus 2. And then we're also going to be seeing here at the last one that is a factor form. If you want to do the factor snowflake, that will work, but we're going to get x minus 2 and x plus 2. So we want to be able to see, 1, x plus 1. We want to be able to see what we're missing on all of these. Once you kind of figure that out, we can all put them together. All of these components seem to be missing something, so we got to be able to add them all in. If I'm looking at x plus 2, this other one has x plus 2, but this side does not, so I'm going to add the x plus 2 to this side. For a common multiple. The next one on the middle, we're missing an x minus 1, so I'm going to add this x minus 1 to this side. X minus 1 will stay in the middle, and then we're also missing an x minus 1 here. Then on top of that, I have a x minus 2, so this is a plus 2. So x minus 2. So our plus 2's kind of go away. We're done with those. Our plus 2's on that side go away. And then we actually have an x plus 1. So I'm going to go ahead and add this x plus 1 here because we're missing it. And we're missing the x plus 1 to this one. So I'm kind of separating them so you guys can see them a little bit better, but these are what we're missing for each of them. Our common denominator between these will be x minus 2, x plus 1, x plus 2, and it looks like x minus 1. So we have all these components that we're missing with these that we want to be able to add in to each one of these individual fractions. We want to be able to add them in there. If we're doing it all over one case, multiplying these to our top side here, x minus 2 times 1. I'm going to multiply these to our top portion, so it's going to be plus x plus 1. And then we also have our last term, which will be multiplied by a negative 2, x plus 2, x minus 1. Okay, from here, all what you really want to be able to do is simplify out all your terms. So we're going to reduce here. Okay, you don't need to expand this out. If it's leaving as fraction form, leave it as fraction form. Hopefully, we'll be able to reduce the top portion out so it becomes a nice value. But I want to be able to kind of keep this video short, so check it. I'll put the answer to these a little bit later for you guys, so simplify it out. The next one that we're going to do here is simplifying out a rational division of polynomials. I like to do mine above and below them so I don't get confused. I can pull out a 7x minus 3 together on the top one. This bottom portion is a difference of squares, which becomes x plus 5, x minus 5. The top portion of our next has to be factored using the advanced snowflake. We always want to look at pulling out the greatest common factor. If we can't, we have to use that. So minus 18 is going to go on the top, multiplied. It's going to add up to give you negative 3. Let's look at 18 as negative 6 and positive 3. We're going to put our 2x on the top of these. The left-hand side can be reduced by x minus 3. That's one factor, and this is our other factor. So because it's division sign on here, I know that that's going to be heading on my bottom. So let me kind of rewrite this, and hopefully we get factor terms that kind of look very nice. So I'm just rewriting the left term, or left fraction. This is our keep. We're going to change this to a multiplication, and we're going to flip these two. So I'm going to put the division sign, and my red terms is going to go on the bottom, giving me x minus 3, 2x plus 3. Okay. Our bottom term is now going to go on the top, but I want to be able to do the factor tree for this. So I'm going to do the factor tree, doing this 2x, 2x. Top side is going to be 30, bottom will be 13, which I know it to be 15 and 15 and 2. No, positive 30. Let's see, that's not going to work out unless I was subtracting them. 30 multiplies to give us 30. 2 and 15, 6 and 5. 10 and 3, sorry. Left-hand side is going to remain the same because we don't need to reduce it. The right side can be reduced down to x over 5. So this will be x plus 5. And now that we all have them in our terms, we can kind of reduce down. As long as they're being multiplied together, my minus 5 or plus 5, 2x plus 3, 2x plus 3, x minus 3, x minus 3. So all we're left is a 7 and an x minus 5. So you don't need to do anything else besides rewriting out your terms. Good. There you guys go. We're going to continue on doing this. Just kind of reviewing our factor terms with this. I believe you have a problem, but I can't remember. But we still got to be able to factor this. One thing that we want to be able to see here is before you even do this, if we were to use a snowflake method on this, and we want to be able to multiply these out, 12x is always going to remain there, and we're always going to have a term on the bottom, right, negative 60. But if we were to multiply 12 and 75, it might be a big number to put on the top over here, so we can't really do that. We can find multiples, but it's going to take us a longer time. The best thing for us to do is to pull out any greatest common factors. And when looking at these, I'm hoping we can pull out a greatest common factor. 3 will definitely work between these. I know 3 goes into 75, 60, and 12. Let's look at that. So 4x squared minus 20x plus 25. And when you pull out that greatest common factor, it's going to be following it the whole time. We're just going to factor this now. I know 4 and 20 and 25 don't have greatest common factors anymore, so we're going to look at the snowflake for that now. And hopefully you see 25 times 4 is going to go on top, so that's 100. The bottom one's going to be negative 20. The middle one's going to give me 4x and 4x. Okay, I know two numbers that multiply to negative 100 adds up to negative 20 is negative 10, negative 10. We can reduce this down by taking out the 2 or dividing up by 2. So 2x and negative 5 is one term, 2x and negative 5 is another. So it's going to kind of look really nice. We're going to keep that 3, bring it down to the bottom, 2x minus 5, 2x minus 5. So we have our two terms here. We're done factoring it. We don't have to complete it any more than what it is. So please make sure you guys follow that. Stop it. Take your time looking over how I did that. Again, greatest common factor, GCF. Number 1 is GCF, always. Okay, so you got to be able to do that. Next one that we're going to look at, okay, is our fractions, in this case, fractional exponents. we can always take these out. So whatever I do here is I look to the outside first. I will, if it's a negative, I'll flip my terms first before I do anything. So I'm going to go and take that in, and I'm going to go and distribute that to each one of my terms. Here and here. This is going to give me 4 to the 1/2. I'm hoping you guys remember what the 1/2 represents. In this case, to let you guys know, it represents square root of a term. The 3a over 2, 5/3 will remain the same. There's nothing changing with that. I don't want to change in the beginning. The next thing I want to be able to do is I'm now going to move my terms down over, and maybe this will help you guys out. I'm going to move that b minus 3/2 over to one side. That's going to go away. And then I'm going to bring down this a minus 2 term. So that top one's going to go away. So if you want to see it visually, whatever's negative goes in the top of the numerator. Whatever numerator is on the top that's negative goes to the denominator. And these are no longer negative, sorry. So let me rewrite that. This will be b over 3 over 2. And this will be positive 2. I'll just write that as a positive. Let's go ahead and reduce that as much as I can. I'm just going to multiply my top ones across. This is 4 root, so I'm just going to rewrite it as a radical. This will be radical 4. It's a horrible one. This will be radical 4. A just turns into just multiplied by a. And then the last one that I have here is my 3 on this side. And we'll rearrange the terms, and then I'll have b as the cube root of b to the 5th power. Okay, we can rewrite them as radicals for us. Let's continue on doing this. I see I messed up some of it, but we're going to try to fix it. Let's go back. Let's go back. I want to teach you guys that one. So we can rewrite them, but I'm already seeing an error in my problems here. I'm hoping you guys are able to see what I saw. We had this on the team test. Square root of 4 is just 2. Let's just reduce as much as we can. This will give me a. Let's leave out the 3, so we're going to leave that 3 out in front. And then we're going to leave this out, and I'll show you guys why. We have that same b on the bottom that we need to take care of. So this b right here, I'm going to bring it to the back. This will give me b to 3/2. And then we're going to have that a squared here. So I'm going to rewrite my terms together. This will give me 6. My a is going to cancel on the top to just give me a on the bottom. And I'm going to get b over 5 over 3, b to the 3/2. So now that I'm kind of seeing it this way, we have our terms that we can actually subtract here. Okay, this becomes b to the 5/3 minus 3/2. We can create a common denominator, so b, I think it's going to be 6 over 10 minus 6 to multiply by 3, so it'll be 9. So we're going to get b to the 1/6 power. Okay, 1/6. So we still have it bigger, so that's going to go on the top. Our final solution will be 6 to the b to the 1/6 over a. You can leave it as a fraction. I'm okay with that. You do not have to put it back into a radical form. But if you do, it's going to be okay. I'll still accept it. Okay, here we go. Okay, we just did another one for quiz for these, so I'm not going to kind of spend time on that. Let's look at this one. Now, in this operation that we have here, these are being multiplied together, so we can actually group them together. If there was an addition, we couldn't do that. We'd have to simplify out, but because it's being multiplied, we can actually group them underneath the same term. So we're going to do that. This will be 3 radical x squared y, which is my first term. And I'm going to get x squared y to the 5th. And let's go ahead and group these together. So we're just simplifying out. This will be 3 radical x to the 4th, y to the 6th. Now I'm seeing kind of things that I can look at here, and I want to kind of reduce this down as much as I can. So we're going to separate them again. Now that I have them grouped, this will be 3 radical x to the 4th times 3 radical y to the 6th. And I'm hoping you can see this one. You need to rewrite it. Hopefully you can see that. This will just be y squared. If we need more clarification for that, what we can really do is write them as 3 radical y to the 3rd times 3 radical y to the 3rd, which will give me y times y. That should have been 8y, not a 3. So this is why we get the y squared down here. Okay. Very similar with this top one, we're going to change it so we get a whole group of x cubed terms times another radical of x. So if we were to combine these, it would give us back to x minus 4. This just becomes x, and we're going to leave the other one. So x times 3 radical x. Okay. So that's going to be our solution to our values here. You can leave them as that. You can put them back in the radicals if you like to. So x to the 1/3 y squared power. Okay, we want to be able to do it in our simplest terms. This one we talked about using cube roots. We talked about the cube root process of today. This time we have square roots, so let's write out all the square terms, or at least some of them. 1, 2 would be 4, 3 would be 9, 4 would be 16, 5 would be 25, 6 would be 36, 7 would be 49. And all I'm doing is multiplying each individual term by squaring it. We don't need to go any higher because I already see what we have here. But if you need to write them out, please write them out. Looking at this one, I know that I can rewrite 12 as a square root of 4 times 3, with the other one being the radical of 25 times 3. So I can split those up. This will be radical 4 times radical 3 plus 5 radical 3, or radical 25, before I reduce that one more time. This will give me 2 root 3 plus 5 root 3. And then what we can also do is just by adding up our terms, we can get 7 radical 3. So good problem to go over. It's an interesting problem. You guys got to be able to do it. We already did a term like this, so I'll just run over this one fairly quick. You want to split up these compound fractions, and then the top and bottom, we got to create a common denominator to create the top as a fraction, and then the bottom one as well. Let me kind of go back. Sorry about that. Let's look at this. We're going to use this as a common denominator. One thing that's kind of nice with this is we can convert this, hopefully if you guys remember, this positive to the same denominator. If we change this, this would be x over y to the y over y. 1 and y over y are the exact same thing. We're just creating with the common denominator. The bottom portion of this, we're going to create the y being our x. So this would be x over x minus y over x. And again, our ones are the same, so we're not really changing it. We're just going to help it along. We're going to create this common denominator for the top and bottom. Adding them up because they're the same base. We're going to get y like that. Adding them up again, we're going to get x minus y over y. Nice. Now that we have this division sign, I'm going to keep my first one, x plus 4 over y. I'm going to change my division sign to multiplication, and I'm going to flip this. Keep, change, flip. It's always going from top to bottom, so this will be y over x minus y. And I think you guys are starting to see it. I think we did with this one already together. And here we go. Okay. Can't reduce this one down even if we try to take out a negative, so it's already in this reduced form. So just leave it. Okay. Now these are the common errors to avoid. Just take a look at that, kind of review those. Correct multiplication when we're using exponents and radicals can be done in certain ways, but when we have operations with addition or subtraction have to be done differently. So just look at that over. Don't get confused on it, and we'll be all right. You guys will be all right, okay? Rationalizing the common denominator. We talked about this before. We had during the rally. Again, we multiply the denominator by the conjugate, and the conjugate we always look at to be the opposite value for this. So this conjugate that we're looking at is always going to be our denominator term, but it's always going to be the opposite operation. So to rationalize it, we're always going to do 1 minus root 2. So whatever operation is addition, we're going to use subtraction, we're going to use addition. So there it is for us. If we FOIL these out because we multiply the denominators together, we should get 1 minus 2. Radical 2 and radical 2 are 1. 1 times 1 is just 1. And our interior FOILs, the O and the I go away. We're going to multiply the top. This would be 1 minus radical 2. Or 1 minus 2 radical over 2 minus 1, which is negative 1. And we can leave it like that. Okay. So look those over. There's some problems in the back that you guys can check out. They're a little bit more crazier, but I'm not going to kill you guys over those, okay? Just for practice, what we're doing here. Simplify negative exponents. My second period class had a lot of you guys. I want to make sure I'm covering that with you. I'm going over what we see here. There's no exponents on the outside, so I don't have something that looks like this to the 4th negative power, so I don't need to flip the fraction. So if I don't need to do that, let's kind of reverse this back. And if we're just given a basic set of numbers, we now want to work outside to inside to solve this out. So one thing that I want to see here is my a to the negative 3 needs to go to the bottom, and the a to the negative 5 is on the bottom. That needs to go up on top. And those are now going to be positive for us. So if I write this again, and the b's, we're just going to keep on going along. So it'll be a to the 5th power. So we're basically getting rid of that negative. This will be a to the 3rd. And then our b's remain the same. B to the 4th, and then b to the 5th. Hopefully you guys remember how to reduce down, but we want to just subtract out the amount of a's we have down below to the top. This will give us 2. The amount of top that we have on is 4, which will leave us 1b. So we're going to leave that as a fraction. This will give us a squared b to the 1st. Now, eliminating negative exponents is what we just did. So if it's a fraction on the bottom, there is no negatives. We're fine. Okay, you don't need to have that 1. We can just write it as a squared. Okay, a squared over b. Leave it like that. If it's asking you to get rid of the negatives, I'm not asking you to, don't do this. You don't need to convert this back to a squared b to the negative 1. We're trying to eliminate negative exponents. So you don't need to write this up. This is bad. So just keep it as a positive value. Okay. I'll try to watch for that as I'm walking around with you guys tomorrow, making sure you guys are up to date. Okay. We already did several problems like this. I'm not going to kind of focus up on those. Okay. We've already done a problem like this. Did a problem like this. Okay. Factor, we covered this today during class. I didn't have time to go through both classes with it. Okay. Grouping by terms, we want to split it down. The term right here, I think we did this one together. Take out the GCF on the left side. Take out the GCF to the right side. And simplify everything out. In this case, we should get x plus 3. Your answer, I'll write this one in. You should get x squared plus 3. Right, x squared plus 3. Yeah, we can't reduce that down any further than what it is. Oh, sorry, minus 1, sorry. It's going to be minus 1. If you're to factor it all the way, we're going to get x minus 1. Now, one step that I want you guys to see here is we want to be able to see whether this can be factored. And luckily it can. This will be x plus 1, x minus 1, plus 3. So this is our factor term. If it can't be factored, let's say we have plus 1, this would be it. We cannot move on. But because it's not, we can change it up. Okay, so keep that in mind as we factor. Factor completely. Factor completely. These are extra review problems if you want to look up. I try to see the very similar problems that you're going to do on the test. So look those over, check those out. If you need help tomorrow morning, please come on by. I hope this helped out. I should get this one a little bit earlier to you guys, but sorry. It'll be uploaded 6:54, so this kind of went a little longer, but it's okay. We're going to get you guys in. So look for pre-calculus test review. You guys have a phenomenal day. Take care, guys. Bye.